It is showtime. It is showtime. Well, thank you all so much for joining today's conversation. I don't know if you caught a little bit of our backstage chatter, but we're just really excited about the opportunity to have this conversation with you. So we want to say hello and welcome to today's webinar, Engaging Learners with Hands-on Computer Science. Thanks for taking time out of your schedule to be here today. And we're going to invite you into our conversation. My name is Ronnie Thomas, and I'm joined here today by my esteemed colleague,
Steph Forbes. I am the Coding and Robotics Channel Manager for Pittsco Education.
And I am the Southeast Education Advisor. Now, before we begin our webinar, we have a few housekeeping items. Now, we're going to be doing a live Q&A chat over in the chat section. So if you have any questions, put those questions there, and we promise that we're going to get to them when that time comes. And if you miss any portion of today's webinar, don't worry. We know your schedules are very busy, and we're going to make this video available in its entirety at the conclusion of today's presentation, and we're going to email that out to all the registrants of this webinar. So before we do our conversation today, we have to give a special shout out to the sponsoring company, Pittsco Education. And I want to show with you or share with you the who, the why, and the what. Pittsco Education has been around for over 52 years. It was started by 3 teachers that put in their own funds because they recognized a need to be able to create items for teachers that they couldn't find materials for certain lessons in their area. So these 3 individuals got together and started producing materials for those teachers and realized that there was an opportunity to reach even more teachers. So Pittsco Education is a leader in future-ready learning, and we're fundamentally rooted in STEM. Why? Why do we exist? Why do we do what we do? As I mentioned, for over 50 years, Pittsco Education has been impacting classrooms around the world. But the ultimate goal, as you see here on the screen, leading education that positively affects learning. We offer a comprehensive range of scalable, hands-on resources and curriculum. We help educators create learning environments that address all learning styles and help all learners find success while solving problems, being creative, articulating ideas, and thinking with their hands. And the what? For more than 50 years, Pittsco has offered a wide range of scalable resources, and we help teachers make learning come to life. Over 4,000 solutions in STEM, STEAM streams, and we currently have served over 3 million students annually. So welcome to Pittsco Education and our conversation on computer science.
Thanks, Ronnie, for that introduction and setting the stage. As the title of the webinar states, engaging students in computer science through hands-on. And so one of the first things we thought we would do is really to kind of unpack what is computer science. We know the mandates are coming as far as the implementation of the new computer science standards within the state of Tennessee. And so we thought we'd take a moment just to kind of unpack what is computer science and bring a little visualization to what is being outlined and described in the standards. And so one of the first things for us to kind of talk about when we think about the different types of tools and resources that will be important for the impact of how these learnings will come into play is really that computer science is more than coding. While coding is an essential part and plays a part in several of these different areas, that computer science is more than coding. And we'll see this when we start to unpack the standards a little bit. but just a visualization of what are the areas of computer science that have been written into the standards. What are some things that we're going to need to be thinking about when we're bringing these concepts, these experiences into the classroom with students, when we think about artificial intelligence and robotics and the impact on society, so technology for good, and data analysis, and how these things don't work in silos, but how they work together, and what are the true applications? What are the students going to need to understand and be relatable when it comes to these areas that help develop that understanding and also that engagement in the areas of computer science? So why computer science? We're starting to see more and more emphasis around the country, around the world, in bringing more computer science learning, more computer science opportunities into education. And so why? And so if we look at the future high demand jobs and where they're going to be, we can see several correlations that align with the infographic that we just looked at. So AI and machine learning. Ronnie was talking about the impact of AI as having on the record industry. We know we have Chat GPT that's come on the scene, and machine learning. So how can we make machines smarter and more efficient? Data analysis. In the infographic, we saw data highlighted multiple times. Networks and connectivity. So how is the Internet of Things going to transform society and the way that we work and the type of skills? And one thing in particular to talk about is we're, again, thinking about what is it that students are going to need to really understand, what type of experiences, where are going to be these areas as they start to progress through their learning journey, where are these jobs going to be? And we see the word specialist a lot. And we talk a lot about the jobs of the future that have not yet been defined. And industries know that they're going to need a workforce of specialists, but they may not know exactly today what those specialists are going to look like. But they know they're going to need specialists in artificial intelligence and how we use data and how we connect things. And so the importance of, as these standards are being implemented, as this learning is taking place in education, that these are the areas of where we're going to see the jobs. And so how are we going to introduce students in a meaningful and engaging way and in a broad spectrum of ways where that are going to fill these specialist jobs of the future? So what's currently happening around the area in computer science from a job landscape, as well as what's currently happening in education? And so again, going back to why computer science is important and the balance of understanding what is computer science and the physical and the digital aspects of the career landscape, but also the way students learn about computer science. So there's currently over 700,000 open computing jobs in the US. Kind of seeing that number, we've started to again see the emphasis of legislature and policies start to pass, and the governors around the country investing in and committing to creating more access and expanding computer science into education, not just at the high school level where we have traditionally seen it, but really focusing on that full K-12. And we're starting to see an increase year over year in the number of high schools that are offering computer science classes, whether that's a foundational course or a pathway through. But one of the concerning statistics when we talk about being able to fill the current workforce, but also we know it's going to increase with the increase of how technology is developing, is that only 5% of high school students are enrolling in these courses. And so we have an engagement problem. We're starting to create more access, but we're not seeing the enrollment and the engagement of students kind of following that trend. So where are these applications happening? What industries are we starting to see a greater impact of computer science happening. We talk about agriculture and the Internet of Things. If we go back to that infographic, in the areas of computer science and networks and data, we have the Internet of Things, which is already happening in agriculture, whether it be in a traditional farm that we think about, or in an urban greenhouse where farmers and agricultural specialists are setting up systems that allow them to, in real time, create dashboards to get real live data, to be able to modify the environment of the greenhouse, or to be able to monitor their crop. These are things that are already happening. And so when we think about what do students of today need to be starting to experience and understand, what types of applications are they going to need to be able to transfer from their learnings into the real world? If we think about machine learning in logistics, being able to train machines to be smarter, that goes back to data, it goes back to robotics, it goes back to coding. And so talking about, the areas of computer science, not working in silos, but working together, and students understanding that and being able to apply those experiences. So specifically, what's happening around computer science in Tennessee? So we're seeing the increase in access of students having the opportunity to attend a school that has, at a minimum, a foundational CS course. We know we will see this trend to continue to increase and broaden as these mandates start to roll out. But again, we have an engagement problem because only 4.3% of the Tennessee students are enrolling in these courses. So again, while the access and opportunity is growing, we're not seeing the trend from a percentage of enrollment, as well as representation of who is enrolling in these courses. So what will this look like in Tennessee as these mandates roll out? And so, in the elementary, we really think about the exploration of the areas of computer science. So developing an understanding, for talking about algorithms, being able to identify patterns, plan a pattern in computer science, and then moving more into middle school where it will be more course focused and having a more specific targeted course that then transitions to high school, where students will have a requirement of a full year of computer science to graduate. And so Tennessee is investing in that K-12 idea in understanding of why computer science is important for students of today, for their futures of tomorrow. So when we look at the infographic of what is computer science, how does that translate into what actually is happening in the standards? And as we think about the types of tools and resources that educators and students are going to need to move along with them in their learning journey, we talked about in those younger grades, it really being more about that exploration. So being able to construct a step-by-step logical code and logical order, and then moving into being able to classify. And so ensuring that the standards have built in that scalability of growing along with students, allowing them to come in and develop those basic understandings, and then progressing them to those more technical aspects of computer science. So what are some approaches to computer science? If we think back to the infographics around the opportunity for students to engage in computer science focused courses versus where we're at in enrollment, we've seen that there is an engagement problem, an engagement gap. And so when we're thinking about what approaches are we going to take when we're bringing in tools and resources and solutions, we know that the primary thing is that it needs to be highly engaging, and that the real world connections, they're more relatable, the more applicable, where students can see that application. We know the higher the student engagement. The importance of workforce skills, seeing that value, that reason why is important. And then the hands-on learning. We know from research and statistics that kinesthetic learning really does support and solidify students' knowledge and understanding. It promotes creativity, the collaboration and the teamwork, all of those 21st century skills. And it also helps support taking abstract concepts and making them more tangible and more relatable, which we also know helps improve student engagement. And while we've made great strides in providing access to teacher training, teacher certification in the areas of computer science, we also know that there is the importance of the education support, that curriculum, that teacher support is there to help ensure that implementation is done with impact and with purpose. And then it's cross-curricular. So not making it one more thing, but making sure that it is very beneficial and aligns with what's currently being taught, especially at those elementary ages. And then going back to balancing the digital and physical tools. We saw in that infographic, you have robotics and automation, you have networks and the Internet of Things, and allowing those opportunities for students to really explore how the world works and how digital and physical technology works together. So what could a hands-on computer science journey look like? When we look at the screen here, there's a variety of ways and tools to bring computer science learning, to address standards with students. And so a lot of it goes back to what is the intent? What is the idea learning scenario? What are the key objectives? When we talk about students being in the younger grades, and wanting to limit their screen time, having tools that allow them to really explore when you're talking about creating patterns, identifying patterns, allowing them to build their learning. You have solutions that allow them to do that through hands-on. As they start to get into the upper grades, you start to get into more higher level in different areas of computer science. We talk about jobs of the future, and we know that there are battery factories and chip plants that are going to be built in the United States over the next 5 to 10 years. Those are going to require a workforce that is comfortable with technology and comfortable with different areas of technology. So when we talk about the chip plants and developing microcontrollers, we have examples of an Arduino education starter kit where students will be learning and understanding how to build something that can power a car, that can power a robot, and how to code it in the applications. When we look at a Tetrix kit, when we talk about mechanical engineering along with coding, allowing students to have that design experience. We talk about modular robotics and coding. We have the Fable system that allows students to quickly iterate, but it models a similar platform that they would see in a manufacturing. So again, going back to the applications of computer science and the types of tools and resources and experiences, students are going to need to help them prepare them for that broad area of computer science. So it's an exciting time. We know that technology is moving faster than ever. And that the jobs of the future are not going to look different than the jobs of today. And students students that are technology savvy today are going to need a different level of being technology savvy in the future. And one of the ways to help support them is through the areas of computer science. We know that that's where the jobs of the future are going to be, the jobs where they're working alongside technology. And so while it's a exciting time, we also know that there's a lot of experience and opportunities to learn and develop a greater understanding of how we can best support these students. And Pittsco Education is excited to be here and to work alongside you through this journey.
Awesome. Awesome. That was great, Steph. That was a lot of amazing information. And we did have a few questions that came through during registration. There were a couple of questions that were laid out. The first question says, what would be three, your three scalable solutions when we're looking at a district, a small district, looking to incorporate it at the elementary, middle, and high school level?
It's a great question. At the elementary level, when we talk about getting students familiar with, and balancing the screen and the hands-on, something like the Bbot that allows students to do onboard coding. So they're physically planning out their code, their exploration. It can be very cross-curricular as well. They can plan their code so that they can go and find the letter A. As we move up into middle school, if you wanted to take a more engineering focused approach when we're talking about coding and computer science, you could bring in UB Tech if you're looking for kind of that entry level middle school plastic building system experience, and then progress into a Tetrix Prime with a little bit more of the metal building system, and also being able to scale the code that they're using. So moving from block-based to C, and then into high school, you could do, if you're wanting to do a mechanical engineering, again, focused robotics, or prepare students for competition. You could use Tetrix Max with the competition in a box curriculum to help prepare them for those competitions.
Awesome. Good stuff. So Renee from Cokeville, we hope that we answered that question for you. The next question comes from Diane in Murfreesboro, and she says, given that a lot of platforms don't align with Google Chromebooks, where do Pittsco solutions fall in that conversation?
That's a great question, and something that we definitely keep top of mind when we are working with partners or developing proprietary solutions, and understanding that that is one of the excuse me, key devices being used. And so 95% of our solutions work on Chromebooks.
Awesome. Good stuff. And our final question comes from Bill in Pulaski. He said he's a first-year teacher considering getting into robotics, and he's kind of concerned. He's thinking that our Tetris platform may be a little too complicated for a first-year teacher. But what resolve can we give him in reassuring that he would be successful using those products?
Yeah, absolutely. And that's a really good question, and a very fair question, and a common question. We know that sometimes the jumping off point for teachers when they're coming in and being tasked with teaching robotics can feel a little overwhelming. And so going back to the approaches to computer science, it's about the educator resources and ensuring that we have the educator, or that the solution includes educator resources. And so if we were going to talk about Tetrix Max, we have both student and teachers guides, because we want to ensure that students have that autonomy to drive some of their learning, and that teachers have those resources and the knowledge to help be that support and that supplemental encouragement and guidance along the learning. But it's really about empowering the students and ensuring that the teachers have the resources they need to be successful and to help the students be successful. So we have different layers and different levels of curriculum that would be able to support that educator.
Awesome. Good stuff. Hey, well, thanks, Steph. I really enjoyed.
We have one more question, Ronnie.
Okay, awesome.
So for high school, what courses titles fit into the computer science requirement? We currently have an engineering class in which they are coding and building robots with UB Tech Intermediate. That's a great question. And kind of jumping off where you're at today. So the next layer that you could move to is to the Tetrix Max. And depending on what you want your focus to be, if you want it to be primarily on computer science, you could bring in the Tetrix Max building platform with Tetrix Virtual Robotics, which is a coding curriculum that utilizes simulation and physical robots. So you have a strong physical digital experience. And we also have a coding essentials curriculum. And then again, going back to that competition in a box, which is that open-ended, more project-based learning. So you could do a combination of starting with the UB Tech Intermediate and then moving into the Tetrix Max, which is going to give your students a couple of different building experiences and also progress them through into a higher level coding environment through the Arduino C platform.
Awesome. Awesome. Good stuff. So Tennessee family, if you're going to be in the area, I highly encourage and invite you to come out and join us at the TSIN event, May 16th and May 17th. We're going to be in the playground area, and we're going to have several of the items that Steph and I have shared with you today to show you how can you equip your students and teachers to exceed the CS standards that you're going to be responsible for in the upcoming school year. We thank you all again for joining our conversation today. Remember that this video is going to be emailed out to all the registrants and the attendees. And if you want to learn more about the solutions and products that we have available, you can visit Pitsco Education at pitsco.com, and you can reach out to me. My information is here on the screen. You can scan that QR code to book a moment to chat and to reserve time if you're going to be out at the TSIN event. I would love to have a chance to talk and engage with you there. My name is Ronnie Thomas, and my colleague Steph, we want to thank you again. Please do not hesitate to reach out to us if we can be of any assistance to you. And once again, from the Pitsco family to yours, thank you so much for attending today's webinar.